One important procedural consideration for successful solar ready builds is making sure that all parties from start to finish of the project are aware of the solar ready requirements. Roof drains and vents may be shown on design plans and drawings, but if the other tradespeople on site ignore this equipment placement when construction happens, then it defeats the purpose of planning in the first place. So the key element in successful solar ready builds is coordination between all parties. This means coordination between the architect, engineers, solar installers, and other trades throughout. Best practices involved in the management of solar ready builds include hiring architects and engineers experienced with solar design, involving a solar installer early on, coordinating between all design disciplines to determine things like rooftop unit locations, exhaust fan locations, roof access, and walkways, ensuring all trades are aware of solar ready requirements and place roof obstructions per the plan. Having the installation manager regularly check that all trades are following the solar ready plan can go a long way to achieving your goals. For those of you who have attended our passive house design workshop in the past, and you can find that at our website, solaralberta.ca, you'll have heard a very similar principle of the importance of getting everyone on the same page.
So now that we've talked about some of the very important kind of process-related things that you want to make sure to ensure a successful solar-ready home, we'll move a bit into technical considerations now. So as mentioned on the last slide, coordination is a very important thing. As well, obviously this is going to depend on the size of the solar PV installation. If we're talking about a 10 kilowatt rooftop system versus a 1 megawatts commercial rooftop system, it'll obviously involve a few different trades and really differ in sort of the complexity that those systems will have. However, the general guiding principles will stay the same between the different sizes of projects. Those 4 guiding principles, which we'll go more into detail on the next slide, are kind of architectural and siting, structural considerations, mechanical considerations, and electrical considerations.
Great. So now let's get into the nitty-gritty, the detail of these considerations a little more. All right, first we have our architectural and siting considerations. Ideally, we have a south-facing pitched roof with a slope higher than 312 for good solar radiance and some degree of snow shedding. The roof should also be relatively simple in shape so that roof area can be maximized for solar on the south-facing roof. Roof obstructions, such as plumbing vents or exhaust fans, should be placed on the north-facing roof or as close to the ridge as possible to maximize the space for modules. For commercial flat roofs, a torch on membrane type roof is preferable. TPO roofs may be slippery in the winter, and tar and gravel roofs pose structural and installation challenges for solar PV. Buildings, trees, and other tall objects to the south of the roof should be considered as they may significantly shade portions of the roof. If there is shading, then there are some solar PV products that are better adapted to shade, which should be considered. We should note here that these are ideal conditions for solar PV in many cases, such as the home I'm in. Other design or cost considerations might make these elements unfeasible to implement, and that's okay. Solar designers and installers can accommodate a wide range of conditions. However, these considerations should be made whenever possible in order to ensure the most solar-ready installation possible.
So secondly, we've got our structural considerations. Obviously, this is pretty important because if your roof can't accommodate the additional loads from solar, then the system will be either costly or downright impossible to install as structural reinforcement is needed, which is a pretty hard thing to do in most cases. So typically, we recommend about 3 PSF or pounds per square feet in order to accommodate flush mount solar PV system, which means basically your solar is going directly on kind of a pitched roof. So you can kind of see an example of that rather on the wall on the top picture there. But if you can think about that wall tilting over, that's kind of an example of a flush mount system. Now the requirements for a ballasted system, where basically the array is held down by concrete blocks, kind of like how you see in the bottom picture. That'll obviously take a bit more loading because of the concrete blocks. So that'll be around 5 to 8 pounds per square feet for a system like that. So that's something we typically see more on commercial systems as opposed to residential systems. So obviously thinking about the structural considerations is important for residential roofs, but one thing to think about as well, especially as electrical vehicles are adopted more nowadays, is thinking about whether your garage can support the additional loads from solar as well. Sometimes what ends up being kind of limiting factor for how much solar you can install on your house is basically your main house roof space. But if you're able to accommodate those loads on your garage as well, then that is great. So that's something to think about as well in the future is, hey, can I put solar on my garage as well? So finally, a solar designer, installer, or racking company should be contacted to give you a preliminary estimate for the solar PV loading on the roof and whether or not your roof is able to take the additional solar loads in the first place.
Yeah, thanks, Nick. And that last piece around garages is definitely going to be important because Solar Alberta has been having conversations lately with the government of Alberta about our hope for the removal of the consumption cap on micro generators. And I know that if we're successful in having that cap removed, then of course we definitely want all those garages to be additional solar homes for solar. So even if there's nobody living in them. So thanks for mentioning that. Thirdly, of course, we have our mechanical considerations, which are a bit more relevant for commercial flat roofs, where there are large mechanical units or gas lines located on the roof. This is similar to the architectural considerations. Essentially, ensure that any roof obstructions, including gas lines for commercial roofs, are grouped to the north side of the roof as much as possible in order to facilitate the maximum area for solar PV.
And finally, we've got our electrical considerations, which there are a few. So first, we want to make sure there's adequate wall space in the electrical or mechanical room for the main inverter. So this would be roughly 2 feet by 3 feet tall for a typical residential installation. Obviously, for commercial installations, you're going to have a lot more inverters. So that's going to depend for a commercial installation. For residential systems, you also want to make sure that a minimum 1-inch size conduit with a pull string should be installed between the main electrical room and the attic. The attic conduit should be above the insulation, so it's not hidden under a bunch of fiberglass. And the main electrical room conduit should also be in a location where you can find it easily in the future. So the conduit should also be run in a way so that it's easy to pull cable for the installation in the future. So avoid, lots of twists and turns in the conduit. And finally, just make sure that the conduit's capped, sealed, and installed to code. Next, you want to make sure that, and this is probably the most important point here, but you want to make sure that the main electrical panel bus rating is upgraded to the next largest size relative to the main breaker. This is done because by electrical code, your bus rating as well as your main breaker size will dictate kind of how much solar you could put in the future possibly. So for instance, if your main breaker on your panel is going to be rated 200 amps, you want to make sure that your installer or your consultant is upsizing that bus rating for that panel to 225 amps, which is the next biggest standard size. This is super important again, because if you need to go back and say you want to install more solar than your panel can handle, it's a very costly and a very time-consuming, well, not time-consuming, but it's very scope-intensive to try and retrofit that panel to replace the main bus. So definitely make sure, if you remember one thing electrically, make sure your bus is big enough. And finally, you also want to make sure that there's a spare breaker space in the panel at the opposite end to the main breaker. So for instance, in that picture, if you imagine kind of your main breaker, we don't have a picture of it there, but let's say it's at the top left there, you want to make sure that there's empty space at the bottom right of the panel for your future solar breaker. And again, that's just to meet code requirements. So if you're, before I go on to that point, I should say for commercial installations, the electrical designs may vary quite heavily from facility to facility. And it's recommended for those more complex commercial installations that you engage a solar consultant or installer to involve with electrical design. Just make sure that everything's designed properly and to code. If you are interested in further reading, a really good document to take a look at are the NRCan Solar Ready Guidelines. It's from a federal agency, but it's a really good kind of guideline that documents the best practices for preparing a building to be solar ready.
Yeah, thanks, Nick. And I know our partner CanRIA was also involved in that NRCan doc, so I'm sure it's informed our presentation today and has been a great resource. When you were describing the electrical considerations, I couldn't help thinking we're doing back to school shoe shopping for my kids right now. And of course, the first thing we're thinking is their feet are going to grow. So we're absolutely buying one size bigger because I don't want to have to buy shoes again in 3 months. So I think the more that we can get home builders and electricians thinking in terms of back to school shoe shopping, the better probably. All right, let's talk a little bit about some of the trends happening right now. We have reviewed the core elements of a solar ready build. However, you all know that folks are demanding even more these days. So lately, almost everyone who is installing solar is thinking hard or sitting on a wait list because they're hoping to purchase either all electric appliances, electric vehicles. Some are contemplating solar storage options, solar energy storage options. Of course, Tesla Powerwalls, I'm hearing a lot of folks talking about that these days. People are looking at essentially products that will complement a solar array. As things like air or ground source electric heating and cooling pumps, induction stoves, EVs, and storage systems come down in price, and as they are incentivized by government, and ultimately as natural gas and other prices go up, these seemingly fringe or niche items are becoming more and more mainstream. So I got a lot of calls about heating and cooling pumps as soon as people saw their utility bills over the past few months. So really interesting shifts there in the market. So for these types of additional considerations, it is strongly recommended that builders consider pre-wiring for 200 amp service, as well as meter-based disconnects to ensure no additional electrical panel or service upgrades will be needed. So I often talk to solar installers, they say, well, we don't really need 200 amp service. And it's not the solar that needs it, it's actually all the things that complement solar that might. So it's kind of like if you're at a buffet, the solar doesn't necessarily need the 200 amp, but all the side toppings that go with it might. So this is of course particularly important if you're integrating secondary or tertiary suites for homes. Again, just a reminder that if you're installing a 200 amp service, as we recommend, then you should put in the next higher electrical panel bus rating that is sold, as Nick mentioned, 225 amp in this case. Additionally, when going EV ready, or essentially making sure that a home has a charger, 240 volt, 40 amp branch circuit should be included at a minimum to any garage or private parking area. Adequate wall space will be needed in the garage or an outlying building that is not a dwelling unit, and the conduits should be even larger than I previously mentioned to accommodate storage if desired. And that will definitely differ depending on the storage that's under consideration.